Hi, everyone. Welcome to a Conveyor Meetup. Today we have Rajiv for Randoli who will be presenting. If you have any questions as we're going through the presentation, please put them in the comments. Just know that I probably won't get to them until the end of the presentation. That way Rajiv has enough time to go through everything. Aside from that, I will send out the slides along with the recording link after probably 1 or 2 days after the meetup is over. And aside from that, if you've been using any of the tools within the community and you have questions as you go through with it, feel free to just ping us on the Slack channel and we'll get someone to help you with that. And Rajiv, I'll hand it over to you.
Thank you, Jonathan. Appreciate it. First of all, I thank you for inviting us to speak to the Conveyor community. It's a pleasure. I look forward to, sharing some of the lessons learned, with some of the recent projects that we have undertaken. Shall I go ahead and get started, Jonathan? Jump in to it right away?
Yeah, you can go ahead and go.
Cool. All right. Okay, cool. I'll give a quick intro to myself. I'm Rajat Tatapattu. I'm the CTO for Randoli. And Randoli, our goal and our mission is to help our customers migrate, modernize, and integrate the applications using cloud-native technologies. And then the Red Hat application portfolio, the Red Hat product portfolio is a huge aspect of it. We work hand in hand with Red Hat as partners. Prior to Randoli, it's no surprise, I've been at Red Hat for over 11 years before I started with Randoli. Worked in engineering for quite a long time before moving on to consulting, and then after that, starting with Randoli. All right, so Jonathan reached out and asked me to talk about one of the customer projects that we did in the recent past, where we migrated a bunch of applications from Oracle SOA Suite to a microservices architecture running on Kubernetes. Obviously, it was on OpenShift, but whatever we talk about today is broadly applicable to the theme that we're discussing today. All right, so so I think I kind of jumped the gun there. I'll talk about the primary drivers for why we moved off, why the customer wanted to move off SOA Suite, the high-level approach we took, some of the implementation details, and then how we leverage a test-driven approach to reduce our risks. We'll talk about some operational concerns and of course some lessons learned that others can also benefit from. Right, cool. So there was a number of key applications that were running on SOA Suite, and the applications that we tackled on. So it was a two-phased approach. It was two applications that handled the payment aspect. It was a payment gateway application. Two applications kind of collaborated together to form the payment gateway, and the customer wanted to move that to, in this case, OpenShift, but they're in keeping with their organizational goal of moving their critical applications to cloud-native technologies, right? One of the other motivating factors, of course, is the very high licensing cost. It was also out of support, if I'm not mistaken. So there was almost an immediate need to move to a newer platform. So it had to be re-architected and move to a newer platform. There was also a lot of concerns with scalability and manageability. So this customer was in the postal business, I'd say, without having to give any names out. And obviously, we all know the surge in traffic that you get towards the holiday season. And sometimes, when you get to Black Friday, you see volumes that are, several times that you would normally see during a regular business day. So there was this surge in volumes that they had to tackle and the business was just growing, year over year, and they needed a platform that can better scale, better handle these scalability needs. In the previous platform, there was it was deployed in VMs and stuff like that. So it took sometimes weeks of lead time to add capacity. But and once the holiday season is over, you actually don't need that extra capacity too, right? So you have to again scale it down. That was a massive manual effort. So there was a lot of these, I would say, management and scalability overhead issues that had to be solved as well, and they decided to move their applications onto Kubernetes, and of course the choice was the OpenShift platform. Right, here's the high-level architecture, and this is also a good slide to kind of bring everybody back to kind of reality about what a typical migration project would look like, right? More often than not, you have to coexist with the existing applications, the existing protocols. Very rarely you would get the opportunity to wipe the slate clean and start from the beginning. So in this case, we were kind of sandwiched between two data power applications. All the front-end applications were using SOAP XML. The cost of replacing all of that was too much, and it was too risky to do everything at once. And on the back end, the book of records was SAP, and the communication was again SOAP XML. So we were kind of constrained there, right? So you'd see any migration project, any large migration project, you will run into these kind of restrictions, right? And our focus was in this, it's whatever that's between these two data power applications, where the payment gateway applications was. But we did have the license to re-architect and redeploy this on OpenShift. So that's what the high-level architecture looked like. We obviously wanted to make sure that we make sure that the work that we put in is future-proof. So in addition to the SOAP interfaces, we built REST interfaces, parallel REST interfaces, and we were able to do that without too much effort using the Apache Camel framework. I'm a huge fan of that Apache Camel framework. It's a lifesaver when it comes to building microservices and any integration type of projects. I'll talk a little bit more about some of the finer details of it and how we were able to do that without much additional overhead as we move through the rest of the slides. And another thing that's kind of worth pointing out, and I already alluded to that in most of these type of migration projects, in addition to working with these kind of constraints, you also have to take a phased approach. So like I said, we took a two-phased approach here. We migrated one part of the application in the first phase, and then another, and that was a smaller component. So that allowed you to assess the risk, learn, adapt as you go forward, right? And also helps build comfort with the business side of the house, right? And so they are because this is a critical application. If this is down, you can't get any of the transactions, the payments in. So we started with that smaller component, and the data power gateway kind of helped us with that aspect, right? So it's almost like the strangler fig pattern. I'm sorry, I don't have a slide to explain that, but that's the approach we took. And currently we are working with another customer, similar approach again. We are rebuilding the new application in using Springboot and Camel, running on OpenShift, but we have this big legacy application on the side, and it has like 32 operations, and we are just building 5 to start with. And then we have the 3-scale API gateway, just kind of like the data power gateway. I just wanted to talk about the other example too, so it puts a little bit more context into what I'm talking here. And what we did was, just like in this case, for those 5 use cases, we are redirecting to the newer set of applications, and then for the rest of the 30 use cases, they go back to the legacy. It's the same thing over here for that smaller piece we tackled at the beginning of this year. The traffic for those SOAP calls were routed to the newer application that we built. The rest was going to the legacy. Now, as we make progress in a phased approach, and here it was a 2-phased approach. The current customer that we are working with, it's going to be a number of phases. So you slowly start migrating more and more functionality into the newer set of applications, the newer set of microservices, and you become less and less reliant on your legacy application. So almost kind of like slowly starving it. So that's why it's called the strangler pig pattern, right? And you will most places, that's what you'd have to end up doing, because it's very hard to have a complete blank slate to start with. So that's something to think about right off the bat, and you need to factor that into your architecture, your design, your choice of technologies, etc. And that's again where Camel really shines, because it's really great at building these, tackling these integration challenges. Let me move on to the actual proposed solution. Now, this is almost kind of like my preferred stack when it comes to building microservices and tackling this type of applications, right? So in order to build our proposed solution, obviously Kubernetes no-brainer, and that is probably for most folks that is the choice of cloud native platform, right? And in this case, though, for this particular customer, they already had an internal team that was championing this, so they had good skills. So it was pretty easy to make them take this up. They also had built a good CI/CD offering around OpenShift at the time, so it was really a no-brainer. They were really ready to go on. Now, there are some organizations that could be fairly early in their Kubernetes journey or haven't even started. If that's the case, then you'd have to also tackle those concerns perhaps before you take on a full-scale migration like this, because otherwise it tends to be a little too overwhelming, especially in terms of the operational side. And I'll talk about, even with this, there were some operational gaps, there were some hiccups along the way. So I would almost always pay attention right at the beginning to make sure that there is a good fundamental understanding of how you should be building and deploying and manage your applications on the Kubernetes platform. Very important. And then for the when it comes to microservices, like I said, if it is on Java, so usually I like Go and Java to build. But ideally I would love Go, but 99% of the applications out there that we deal with is in Java. And the Apache Camel is a great toolkit for building microservices. Why? Because at the heart of any kind of microservices implementation, you have an integration problem. And Camel was purpose designed as an integration toolkit, as an integration library. Tons of support for all kinds of protocols and transports and data formats, right? Like you name it. Like there is a component for SAP. There are obviously first-class support for JSON, XML, so for any of the messaging library. So it's really a brilliant piece of technology to use. It's also very well tested. I've used this now in the last 4 or 5 years on a number of mission-critical applications, and they've all gone well. And one of the reasons is that it really cuts down your risk because you're using a bunch of well-tested components. So the developers are really focused on mostly writing the transformation logic, business logic, and they're less focused on dealing with building complex error handling or connectivity issues, or I would say, processing things in parallel. All of those, heavy lifting is done by some of these components, and it's really easy to put these components and pieces together to build your pipelines, right? So Camel takes that. Today it's not really the day to kind of go deep into it, but at a very high level, Camel takes this pipeline approach they call the Camel routes, where you can use the Camel DSL, or you can take the XML approach. I prefer the Java DSL approach, or the Groovy DSL approach, where you write your flow in that DSL and you put these components and the pieces together. And it's brilliant because, when people look at that Camel route, it's almost easy for people to see what the logic looks like, what the flow looks like. And the other aspect that I'll talk about a little bit later is the first class support that Camel brings to the table, that really helps you cut down the risk when you're doing a migration project like this. And I'll talk a little bit about that in the next few slides. I also want to quickly talk a little bit about business rules. So most of these applications will have business rules, sometimes very little, sometimes quite a bit. In this case, the payment gateway application, a lot of business rules. I think closer to about 100 odd business rules. And in this case, what you want is to look at something like Drools to ensure that there's a more structured approach to how you handle your business rules, right? Again, not really the forum to kind of go deeper into it, but at a higher level, what it gave us is a declarative approach to writing these business rules. Otherwise, what ends up happening is, if you look at some of these legacy code bases, even the one that we are dealing with right now, so many if-else conditions all over the place, very difficult to manage, very difficult to reason about, and it makes life really difficult later on. So from a manageability perspective, right, with the rules, with Drools, we were able to, this is again an open source project. It helps you to externalize the rules and put it into a very nice, almost a Java package-like structure. And these rules are very, it's very readable. They're very, it's almost self-documenting, right? So that helps you to, at a glance, go and figure out where these business rules are. And then also the visibility in how these rules are executed. Again, I'll talk a little bit about that when we talk about operational aspects. At a high level, what we gave them was the ability to, when you punch in the transaction number in their Elk dashboards, you will see all the rules that were executed on a particular transaction. That's pretty powerful for an operations team, especially if they're debugging a custom issue and they want to understand exactly how they arrived at this decision. So Drools gives you that ability to do that. All right, cool. So we did talk about this. I think I kind of almost spent most of what I wanted to say here, but I did talk to you about having that SOAP. We had to support the SOAP interfaces, but also want to make the application future-proof. So you want to have a parallel set of REST interfaces. With the current customer that we are dealing with, too, again, a large migration project, similar story. Now, in a situation like this, what really works is to have a more neutral business object model. So we noticed that in both cases, and in the other migration projects we started, sometimes, like all of these protocols and protocols and formats have their own little quirks, right? So sometimes that model is a little bit more, influenced by these, various idioms and these little, quirks. So what we usually do is we take a step back and kind of look at what the business domain looks like, what the business objects should look like, and we created like a neutral set of business objects, right? That represents the business, that can represent the business flow or the actions that are supposed to happen. And then what we do is, whether it is SOAP or whether it is REST, we can easily map from the SOAP model into that neutral business object model, or from the REST model to the business object model. It's kind of like, if you're familiar with the whole API model, where in the front end calls you have like the data transfer objects. So it's kind of similar. So you kind of take, you have different object models, but you map it. And Camel has first class support for transformations and things like that very easily. So that helps you to map in, and you can keep your business object model very clean. And with minimal, because all the business logic and the rest of the flows were based on that, I would say that more cleaner, streamlined business object model, it was pretty easy for us to, once we did the SOAP interfaces, pretty easy for us to add the REST interfaces, because it was a pretty trivial transformation from that REST model to the, it was almost like a one-to-one map. So we just, without much overhead, we were able to get it. Camel has a few other nicer things like the micrometer component. So metrics, especially if you're dealing with microservices, you want to kind of understand, metrics for various aspects of your system. Error handling is key, right? Because before you had this big monolith, either everything works or kind of nothing works. Now you broke things into multiple pieces. You can have partial failures, right? Again, don't want to go into too much detail, but one of the downsides with microservices is, or rather, I wouldn't say downsides, but one of the complications is this ability to handle errors, right? You get partial errors and all kinds of failure modes. Camel has a brilliant exception handling policy, or error handling policies that can really help retrying and error handling, that can really make the developers' life easy. So they're very productive when it comes to this. So they don't get too bogged down into these details, right? We use their circuit breaker pattern to handle certain downstream communication. In this case, SAP couldn't handle certain interactions, so we'd have to be careful about not pounding the downstream systems too much. And then in this case, we talked about tracing. We used Camel's skin tracing that supports the open tracing format to get a little bit more insight into how these applications behave. So again, for all of these things, we use these standard components. So there's very little that we had to do as the developers or the architects to kind of implement some of these things, and we just focus purely on the business logic. All right, so I did talk about Drools engine, and we followed a particular pattern. I already talked about the benefits of it, but very briefly at a very high level. I'm a big believer in running the Drools embedded. What we did was, for each stage of the flow, certain rules were applied. All of those rules are packaged into a particular Kybase. So this may sound a little bit, if you're not familiar with Drools, you may not understand some of the terminology, but if you have further questions, please feel free to contact me afterwards. But what we did at a high level was, we created Kybase is like an instance of a rule engine with a bunch of rules. Those were plugged into the different stages of a flow or a route, we map those business objects as facts into the rule engine, and once the rules were evaluated and we had an outcome, we progressed on to the next stage. So certain decisions were made along the way. One of the good things about this approach that I have loved and have really saved as skin is the ability to write some JUnit test cases around your various rule executions. So at each of these stages, we know what the business rules are, and we were able to write some targeted unit test cases using the Camel JUnit support. And that really helped us cut down a lot of the risk, because we knew what the rules were going to be. We knew what the outcome was supposed to be. So we were able to write those test cases and we had existing payloads, so we were able to replay those and figure out and iron out those issues. So most of the, I'd say 80% of the issues were actually figured out before we went to integration testing, because we wrote those unit test cases. So it's fair to say that we actually took a more of a test-driven approach there. And like I said, Camel has first-class support for test-driven development. Let me get to timely topic. So it's not just for Drools. I think overall though, I think the main reason why we were able to, especially the payment gateway application, why we were able to successfully execute this project is testing. We took a test-driven approach from day one. We made sure that we wrote unit tests for those Drools, the business rules that I talked about. We wrote test cases at the route level. We also wrote overall test cases from using the Karate framework. So it's another open source framework that you will see. So the Karate framework can actually work with both the REST and SOAP payloads. Because the requirements weren't written in stone anywhere, we had to really look at the existing code base and reverse engineer. I mean, I don't need to tell you like how risky that approach is, right? So the only way that we were able to verify was to ask the customer, get us actual payloads, get us the requests and the responses, and we know that those are valid, right? And then we use the Karate framework to write a whole series of integration tests that played this payload and validated against the existing outcome from the previous system. And that alone helped us to, like I said, find a lot of the issues before we even went to integration testing. And all of those tests actually ran as part of our build for each of those microservices, because there's a few microservices, it wasn't a big deal. But those integration tests and those unit tests around the business rules was a real lifesaver. And we tweaked them as we better understood the system. We made sure that we kept on adding those payloads from those various corner cases and other scenarios as they tested. Like, so even during the integration testing phase, when they found issues with a particular payload, we made sure we took that and added another test case with that particular payload. So that way we were able to make sure that everything got executed the way it was intended to be with the existing system. And that really saved us, because there were certain cases, because we were not really SOA Suite experts, there were some cases where we weren't exactly sure how it was handled. It was old code. The developers who wrote them have either left the company or they were no longer in that team. So that was a real challenge. And you would find this with most migration modernization projects, especially like older code bases, right? We are facing the same thing with the current customer as well. Nobody in that team knows the code base well, nor do they know all the business rules and requirements, because things have evolved over the years. Nobody has documented it. So it's a real challenge. The only source of truth, unfortunately, has been like how it functions at a higher level. So those could be your payloads, or those could be certain outcomes, right? So I'd recommend, like, if you're taking on a migration modernization project, it always pays good dividends to kind of collect those existing payloads, or understand what those existing outcomes, and start writing test cases, so you have some form of framework to verify what you're building, because you may end up missing critical functionality if you don't pay attention to that. There's no other way, because it's kind of hard to always look at the code and completely understand, especially if it is older code and no one is there to kind of tell you what the original intent was when people write those tests. Especially this really matters mostly around corner cases and obscure cases, which almost always trips you in production later on, right? And can be pretty costly. All right, so let's talk a little bit about the operational view of it. I think I went a little bit faster than I anticipated, but that's okay if maybe we'll have a few more minutes for questions. Again, This was actually given to me by the customer itself. They ended up from the customer side, the architect ended up co-presenting with me at Red Hat Summit. We talked about this use case. So really, one of two things that I kind of want to highlight here. One is that they already had a set of they had a CI/CD approach that worked for that organization, and there was a team that was championing it. I think that's a huge part of the success, because it really helps us to not focus on that aspect and just worked on migrating the application. The second aspect was obviously the testing, which I talked quite a bit about, and the third one was the distributed logging aspect, as well as the metrics and monitoring. So it's very important, especially when you take on a microservices project. You should have the ability to reason about, right? Because previously, everything was in the same code base. You can make sense of the logging by looking at a single log file, right? Now with microservices all over the place, so you need a way to obviously you need a log aggregator like Elk or Logstash or Graylog. I meant Splunk or Graylog to aggregate the logs. Number two, you need a way to correlate and coordinate all those logs together. So we paid a lot of attention into how and what we log, as well as how they can be correlated, right? So we made sure that certain fields were indexed in the logs properly, so you will be able to like the correlation IDs, so that we can filter by the correlation IDs and filter by the various services or components, and also kind of almost do like a retrospective after we've got to a certain stage. We looked at the logs to see, can someone look at these logs and figure out what's going on, right? And then I think we were a little bit obsessed in figuring out how people could understand how the rules were executed. We made sure that we logged all the rules that got executed, but more importantly, also like what were the facts that was supplied, what were the rules executed, what was the outcome. So by looking at a particular transaction, the operational team was able to piece together, how they arrived at the decision, right? And then we worked a little bit back and forth to kind of fine tune that. And then also the metrics. The metrics was a lifesaver. I'll talk a little bit about that. So it's right here. So I'll start from there. During performance testing, we found out that there was a bit of a memory leak, and initially we didn't know where to look at, but we realized that it was actually in the JVM's native memory. It was it was just growing quite a bit, and then it turned out that it was an issue with the Camel neti component, and we ended up actually providing a fix upstream. What's very interesting was the customer worked together with us, and actually the actual fix, we identified the issue, but someone from the customer actually worked together, did majority of the work for fixing that, and we provided that upstream. The only reason why we were able to identify it really early in the game was because of the metrics and the monitoring that we had in place using Prometheus. This made a huge difference, because when we made changes later on, we were able to make sure that at least it's performing better than what it was before, at least at the baseline level. And we were able to execute a lot of the last minute fixes and build that confidence that we were able to put this into production without any performance concerns. And obviously we tested at 1.3 X, as well as I think 2X test. There was a 2X test that was done as well, perhaps a little bit more than that, just to make sure that we can handle any extra surge that you haven't seen before. With Kubernetes, it was pretty easy. You can scale easily as many instances as you want with just a with either click of a button or just I used to say that before, but if you're following a bit of a GitOps type of approach, it's a simple change in Git to increase the number of replicas. But those metrics really made a difference. And to get to that initially, and that's why I want to talk about these operational challenges. If we didn't have that infrastructure, we would have been blind for the most part, and we would have spent more time trying to debug and figure things out. So going back to the beginning of my presentation, if you're building things on the Kubernetes platform, you almost always have to think about these operational aspects before you move anything into production, whether it is distributed logging or whether it is tracing or whether it is metrics, because the value of those towards the latter end of a large migration modernization project is, even if the greenfield application is immeasurable, it really helped us to understand on one side for the performance teams to figure out if the performance was great, on the other side for the integration testing team to figure out if we are firing all the rules that we were supposed to, the outcomes were the same, because we had those visibility from the logging side. It made it very easy to debug and find what was going on, and along with the testing, it made a huge difference, in the outcome. So a couple of things. Let's in case people were interested, I just put some details about what we ended up doing, right? Like injecting some of the correlation IDs using CXF interceptors, right? We are using the CXF because we use Camel CXF component for handling the SOAP messages. Also, pretty important to have log messages at key points, and we paid a lot of attention to this. I know I keep repeating this. More often than not, you find like people end up logging all kinds of garbage. So we made sure that this was something that right from the beginning we set strict expectations as to like those log messages has to be in a particular format. It has to follow a set of standards, and pay attention to the levels. More often than not, people put everything at 1 or info, and you have way more logs or way little or way less when you go to production, right? So we paid attention to not just what we're logging, but also the categorization and the level at which they are logged. That extra time spent on that made a huge difference towards the back end of the project, because logging became a pretty crucial aspect of how we were able to debug certain issues, as well as now both systems, like the entire system is now in production, how the operation teams are monitoring it at the moment. All right, so I think I've spoken about most of these points in some form or shape so far. And in any kind of migration modernization project, there's a lot of unknowns, and it'll seem almost intimidating to start with. So you'd have to figure out a strategy on how to kind of tackle this piece by piece. Like as they say, how do you eat an elephant? It has to be one bite at a time. We've tackled some very large migration projects, and two things that we've learned is that you got to take a phased approach and have a plan in place, not just from a architecture technology perspective of how you're going to tackle it in phases, but an operational plan to do the same and a business plan to do the same, because it has to make sense at the business level too, right? Like it might look great from an architecture perspective, but you have to make sure that the business side of things are also satisfied, so that existing customers are able to continue their operations without being affected, and the revenue being impacted. So you need to look at all of those things, and you have to almost always think that there will always be all kinds of unknowns, because you're dealing with maybe legacy code, maybe you're dealing with things that maybe even the customer may not have expertise in. Right. So, take a bit of a step-by-step approach and plan and budget for the unknowns, right? I've already hopped on like enough on the distributed logging aspect. I think without that, in a microservices containerized world, you're literally dead in the water, right? So you need that. I think one of the things that took the folks on the customer side a little bit by surprise is not understanding how JVM memory works in the containerized side of things, right? I think the story is becoming a lot better, but like just because you give the pod X amount of memory doesn't necessarily mean your JVM is getting the same, right? So the operations teams initially not understanding that was a bit of a problem. So helping you need to understand how the JVM works and that how the JVM gets its memory allocated, how etc. So they were just monitoring the pod memory and didn't know about or didn't pay much attention to the JVM memory or how the memory is being allocated. That caused a few issues. So if you're doing Java applications, learn how your JVM behaves in that container, and what are some of the tunables that you can use to influence that behavior, right? So that's something to pay attention to. I've already talked about metrics, very important. So in one of the cases that we were dealing with, we ran into this issue where, because I think you saw the original picture where they were right over here. There were several hops, right? We we got to a point where we were getting during performance testing, we were seeing massive latencies all of a sudden, and there were several interactions that went through data power. Some went all the way into SAP. Some went into some applications within data power itself. And because we had detailed metrics around certain calls, we were able to pinpoint what that issue was. So that's important to have. It's not just like, again, just like the distributed logging, think about how you can, how the operation team can visualize how the latency, because you have so many different points that we have to integrate and fetch the information to satisfy a particular request. How you can measure the latency and the performance around those different integration points, endpoints. So by paying attention to that and building your metrics model around that, it makes your debugging a lot easier. So we were able to, with a little bit of analysis, pinpoint where it was happening, and we were able to rectify the issue. It was, strangely enough, we figured out that it was an issue with the SQL database. There was this component that was talking to the SQL database that that was taking a lot of time due to a way how, if I recall correctly, how an index was set up. So anyways, and it's important to have good insight into how your applications behave, so that you can not just figure out issues, but also when you fix something and make improvements over time, you have a consistent way of measuring your performance, right? Because we had that baseline and that model, we were able to confidently push last minute fixes without worrying about performance or and the test suite without anything else going wrong. So very important to do that. The last point is, this is more Camel specific. You got to kind of investigate how everything works underneath. In this case, this bug that we noticed with the Camel Netty component actually was able to figure this out, because this was used. Now, Camel is a very highly tested application framework out there. A lot of people use it, right? So even in the upstream, developers were surprised to find this issue. But this issue only surfaced when we used it with the circuit breaker component together. So always pay attention to kind of what goes underneath the cover. If you feel like something is off, dig a little bit deeper. We had to look at the upstream code base to figure this out. But otherwise, I think would have been going around in circles. So we were lucky. We just took the decision. You know what? Like it seems something is off. Let's look at the code to see exactly how these components are working. So that's at a high level, I guess, our journey and where we got here is also based on some of the other projects that we've done in the past, right? Some of these patterns and some of these ways of doing things was based on previous projects. And we are now carrying it forward to some of the other large-scale transformation projects that we are dealing with as well. And just to wrap up, I think we are just in time, I guess. Good timing. We have some 15 minutes for questions if anybody has. Just to wrap it up, I'd say that it definitely pays attention. Take into account that like a migration modernization project, you can just think of it as an isolated piece. There's so many aspects and components that are connected to it, so you almost have to take that into account and take a phased approach. If that's the two things that I can say, is to take more for a phased approach and like take a look at the overall picture, including the business and the operational aspects of it. And thank you. And time for questions if anybody has anything. Hopefully I didn't go too fast, Jonathan.
No, perfect timing. So everyone, if you have a question, feel free to put it in the comments or in the Slack channel. So the first question that we have is data power running outside of OpenShift? If it is there any consideration to run it in an OpenShift container?
Data power was running outside of OpenShift. I don't know if they have any plans of running it within OpenShift, not that I know of. I also personally don't know. Data power, from my understanding, is data power is more of like an appliance-based thing. So I don't know if you can even run it in. Again, I'm not an expert on that, but I know in this case it was like they don't have any plans, at least immediate plans from what I know, to change that. Nor do I'm sure that like whether data power is something that can run out, because it's, from my understanding, it's like an appliance-based thing. It's just the software plus the hardware part. But correct me if I'm wrong, but that's my understanding. I'm not an expert on that.
Okay. Okay, the next question is regarding business rules. You mentioned Drools, but how simple is it to migrate complex business rules from Oracle SOA Suite business rules component into Drools?
Oh, that's a great question. So when we looked at the existing code base, it was a mixture of, they used like truth tables, and then they also use not truth tables. They were using like decision tables, and there was a lot of if else type of as well. So it was we worked with a business analyst from their end to kind of understand them. We were able to, so whatever that was in the decision tables was actually pretty easy to understand. Whatever that was outside of the rules component, buried in the code in if else conditions, we documented that, worked with the business analyst to understand the intent so that we are not misunderstanding anything, and then we migrated them into Drools. We also, like, what I usually recommend is that when you're when you're doing that approach, try and take more for like a holistic approach, like take a step back, look at the whole thing, and work with someone who understands the business side of things to figure out a bit of a categorization of it, like almost like a taxonomy. And then just once you have that understanding, then it becomes easy to make that migration into Drools. Yes, there's also a bit of a learning curve if people are not familiar with Drools, but I think once you get through the initial hump, it's it's not that hard. And that's one of the questions that the customer had, like, it's great that you guys are doing this, but we got to maintain and manage this. Is this doable? So in that, and they have like an architecture review board, and this was one of those questions that was asked pretty strongly, and we worked with them through a number of sessions to show what the approach we're talking about, the test driven approach that we were taking as well, and then how we plan to help them understand what we did in terms of Drools, and how easy or hard it would be for someone who knows Java to kind of learn the syntax and stuff like that and get. So we kept it very simple. We didn't write like elaborate rules. We just pretty much kept it simple and made sure that it's easy for someone to understand and manage. That also comes with that original understanding of how the business rules are structured, right? So it makes sense. Someone from the business can then guide the developer to also understand from a business point of view how they work.
Okay, awesome. And I guess this is just kind of a follow-up from the previous question around data power. They said that there's a virtual version / container of data power. So just
must be. Yeah, I don't know much about it at all. There must be a reason, but my basic understanding was that it's a bit of an appliance-based thing. One of those appliance-based old school type of things. But I know at the one that we worked on was definitely that. Whether they plan to migrate, I haven't heard anything yet. But I can ask them and see. And perhaps someone from IBM would have probably a better idea of what exactly the future plans for the data power thing.
Okay, that's fair. I don't see any more questions, so I think that's it for today. So everyone, thank you for joining. Rajiv, thank you so much for the awesome content. And
you're very welcome. Isn't that like a SAP based one?
Or? So that they were saying it'd be a good topic to have one more focus on SAP modernizations.
Okay, gotcha. Okay, cool. Yeah, we just to clarify though, we didn't touch anything with SAP at all. That was the book of records, and we just made sure that we handle the transformations into SAP. And I don't know about the upstream version, but I know the Red Hat integration bundle has a SAP component, which I know is only available through the product version. Has as an SAP component that simplifies this, calls, this RFC or RFC and TRFC calls. That's what we ended up using in this case. Yeah.
Okay. Well, awesome. I'll see everyone next time. I'll send out the recording link and also the slides probably next few days. Bye, everyone.
Thank you. Thanks again for the time and inviting us to speak at the Conway community. Thank you. Take care. Bye.